Currying stands for the idea that each function we are working with accepts at most one parameter. In order to motivate and understand the idea of currying, let us take a look at a scheme function that takes three parameters, a, b, and c. What happens in the body is not really relevant for our discussion. When we call f3, we must supply three actual parameters. If we only supply a single parameter, we get an error. And the error message is quite obvious. Three expected arguments, only given one. Now let us try to rearrange f3 such that it can deal with a single argument. And it happens here. f3 now takes a single parameter, a, and it returns a function which accepts the two remaining arguments. And when these are supplied, the function does the same job as we saw in the original function. So let us try to apply this function first. Well, we supply the first parameter, and we don't get a very useful result, but we get the expected result because it returns a function. In order to get the job done, we must split the application of the function in two parts. First, we apply f3 on the first argument, and the next pair of parentheses represents the call of this function on the two remaining parameters, and we get the result. In order to drive this to the limit, we actually need to have three levels instead of two levels, but we can easily introduce this, and we are doing it here. So now we have curried f3, first taking this parameter, then taking the b parameter, and finally taking the c parameter, and doing the same job as we decided originally. It is of course quite tedious to manually rewrite our functions in these convoluted ways in order to accept a single parameter, in order to curry the function. So therefore we will in a short while see how we can define higher order functions that transform ordinary functions with arbitrary parameters to curried variants. But before that, let's take a look at the signatures of the function involved. Here we call it f. So a signature of a function with three parameters is of course this signature. So in the domain there are a cross product of a, b, and c, takes three parameters, and the result is of type D. When we transition to a curried version, we are working with a signature like this. And well, the way to understand it is really to be right associative here. So this is the signature I mean when I write this. So here it's clear that we supply one parameter at a time. So when we have supplied the first parameter a, we get a function of this signature, which when we have supplied the parameter b, we get this signature, and finally when we have supplied c, we can obtain a value in the type D. So currying brings us from this signature to this signature, which is the equivalent of this signature. Now let us show the higher order functions that transfer between curried and uncurried functions. The first is curry2, which takes a function f of 2 parameters and returns a curried variant of f. So an ordinary function of 2 parameters in, and out comes a curried variant of f. This can of course also be done for more than 2 parameters. So here we see a variant that takes, where f takes 3 parameters, and this is the result. The 3 parameters of f is clear from this application form. The other way around, if we have a curried function and we want to come back to an uncurried function on curry2, now f is assumed to be a curried function with 2 levels, and we return a function, an ordinary old-fashioned function of 2 parameters, and what happens inside is that the curried function f is called such that we get away with supplying the 2 parameters to the resulting function. And this can also be done for uncurrying with at level 3 here, in the same way as we had curry 3, now we have uncurry 3. You may wonder if it is necessary to program curry 2 and curry 3 and uncurry 2 and uncurry 3 for specific numbers, as I've done here. In other words, is it possible to generalize this currying and uncurrying to n, and to program generally curry n, where n is a parameter, and uncurry n, where n is a parameter? We'll leave it as an exercise, as a good exercise, to work on this problem. The exercise is in the teaching material. Now that we have defined our curry and uncurry function, let us play a little with them. Here's the original function f3, and now we are able to curry this function automatically. So we pass f3 to curry3, and we get a curried variant of f3 here bound to cur f3, and let us apply it. So we apply it here, and we clearly see that we supply 1 parameter at a time, and we get the same result as f3. We can come back to the original function. So going back simply by uncurrying cur f3, and now we should be back to our original function, back and forth, and it seems to be the case. Currying is most elegant in these programming languages that apply this syntax and this notation for calling a function f on a and b. So this way of arranging a function relative to its parameters in an application is called juxtaposition, på dansk sammenstilling. This is Lisp syntax and scheme syntax, so it is fully parenthesized prefix notation, and this is the old-fashioned, well-known way to call a function, where we have both parameters and a comma. So the traditional way of calling a function is, in my opinion, the most clumsy way. This way of calling a function is the fully parenthesized way, is unambiguous. So when you supply all the parameters, you are always able to see the structure in our applications. This way is the minimalistic way to call a function. There are no parentheses, there are no commas, there's no fuss, and it happens to be a very convenient way to combine this with currying. And the reason is that we can simply supply as many parameters as we need. If we supply enough parameters, like for example here, we get a result, if we only supply a single parameter, we get a function that waits for the final parameter to be supplied. The same idea can be used in Scheme, but the penalty is a lot of parentheses. So my conclusion is that currying works well and in a natural way with languages with this syntax, for example Haskell, and currying is less attractive in Lisp languages with fully parenthesized prefix notation.